I am on page 36 of the exercise book. I'm looking at question 29. The following table shows the prices for toppings at a pizzeria. Toppings include mushroom and onion and anchovy. You can get 1 topping, 2 topping, or 3 topping. What would be the cost to order all of the available offerings of this pizzeria, assuming each pizza must have at least 1 topping? Well, this is, let me think. I think the best way is to list the possibilities here, at least to start with. There are 2 or 3 ways to do this, but if you get a 1 topping pizza, you can get mushroom, you can get onion, or anchovy. That's for 1 topping. If you get 2 toppings, you can get mushroom and onion and anchovy, or mushroom and anchovy. And if you get 3 toppings, you can get mushrooms, onions, and anchovies. The order doesn't matter. It's just a matter of which number of toppings you want. So the question is the cost of all of those. So there are 3 ways to get a 1 topping pizza, and those are $6.95. There are 3 ways to get a 2 topping pizza. Let me be sure I have them all. I do. And those are $7.95. And then there's 1 way to get a 3 topping pizza, and that's only 1 of those $8.95s. So $6.95 times 3 is $20.85. $7.95 times 3 is $23.85, plus that one that has everything on it. So we just need to total up those choices, and I got $53.65. So if you call the pizzeria and say, I want 1 of everything, you would be looking at answer B. And I'm going to check these as I go. Number 29 is B. All right, number 30. How many different floral bouquets can you make if each one contains 5 of 7 available flowers? So that is a combination of 7 choices. Choose 5. And I'm going to use the calculator here. I will have to change some numbers around. 7, choose 5. So all clear, 7 shift to 5 equals 21. And I like answer A for that one. Let me check. Number 30 is A. Number 31. Keena needs to select 2 friends from a group of 5 to invite to dinner. Now I have to sort through 20 possible combinations, she says. Is she right? If not, what is her mistake? Well, looks like it should be 5 in the group, choose 2. So she says this will be 20. Let's see if we agree. I don't think so, but we'll see. 5, combination 2. So 5 shift 2, 2 equals 10. Because remember, she would need to eliminate the redundancies before she started to look. So no, she is not correct. So E is eliminated. That says she's right. So let's do them one at a time. So there's A, B, C, D, and E. She is not right, so this is a false statement. D, she should have found 5 factorial. Well, 5 factorial is 120. So no, that's a false statement. C says she should have used the fundamental counting principle. No, because she's not really counting, she's choosing. So I would say that's a false statement. She's choosing, not counting. B, she should have added 2 and 5. Well, that's just 7, and we're looking for a 10. A says she found the number of permutations. Well, let's see. 5 shift 1, 2 is 20. Yes, that is exactly what she did. So I like answer A for number 31, and that is correct. Number 32. To find the number of combinations of 3 items out of 27, you could find the number of permutations of 3 out of 27 and then divide by what factor? Well, if you know your formula, you've got this one. You divide by k factorial. So this one would set up to be combination of 27, choose 3, would be permutations of 27, choose 3, and you will divide by 3 factorial. And 3 factorial equals 6. So I like answer C for this one, because 3 factorial is 6. Number 33. I forgot to check that one, but I'll come back to it. From 7 possible candidates, a club will choose a president, a vice president, and 3 members of a steering committee. How many different ways can the selection be made? Now, the president and the vice president are going to matter. The order matters. So it's once we get to the steering committee that the order doesn't matter, because all those positions are equal. So to choose the president, there are 7 possible choices that you can do. To choose the vice president, there would only be 6 because we took out the president. To choose the steering committee, that would be a combination of 5 left out of the 7 original, and we're choosing 3. Okay. So, we're going to have to find this part. I'm just going to abbreviate that committee. Now, hang with me here because we got some work to do. I'm going to use my calculator to do this just because it's faster. And we've got enough to worry about here. So let's bring this right up here and do the math. We're going to change this to 5. Combination 3. So 5 shift 2, 3 equals 10. And then we need to use the fundamental counting principle to say 7 times 6 times 10 is 420. That's a good question. And I like C for that one. Number 34. How many different ways can you award a first prize, a second prize, and 2 honorable mentions from among 8 contest entries? Well, first prize, we have 8 possible choices. Second prize, we have only 7 choices. And then 2 honorable mentions, we have 6 to choose from, and we're choosing 2 of those. So let's try this on the calculator. We have 6, choose 2. That's 15. And then the fundamental counting principle tells us to multiply all of those choices. So 8 times 7 times 15 is 840 different possibilities. So I like C for number 34. And then finally, number 35. Which has the greatest value? 4 factorial, that's 24. Combination, 8, 6. This is testing your calculator ability. That's 28. Permutation, 7, 2. The number of ways to choose 3 books from a list of 7. Choosing is combination. So 7 shift 2, 3 is 35. And then the number of ways to arrange, that's permutation. 5 books on a shelf. So 5, choose 5. You could also do factorial here because you have those. So I'm going to go with E on this one. And let me go ahead and check my answers. I'm going to start with E since I'm right, or 35, that is E. 34 is C. 33 is C. 32 is C. 31 is A. 30 is A. 29B. 28C. 27B. 26A. 25B. 24D. I can't remember if I checked these. 23C. 22C. Those were the beasts. We did check those. 21B, 20D, 19C, 18B. Where's 18? Did I not do it? Oh, there it is. 17A, 16E, 15D as in dog, 14C as in cat, 13B as in boy, 12B as in boy, 11C, and I have a question mark there, so must not have, I don't know what that was for, but that's the right answer. So 10C, 9C, 8D, as in dog, 7C, 6D, 5D, 4C, 3E, 2D, and 1B. All right. We got all of those right. It was not an easy lesson, in my opinion. And I will see you in the next lesson where we will look at the next skill. And I believe it's probability in lesson 2.4. So I will see you soon. Bye-bye.